All right, this is a meaty video where we're going to talk about all the ways to solve quadratic equations. The only method we will not discuss is completing the square in this video, but we'll talk about all of the other methods. And I want to keep this at maximum 15 minutes. So if you need to pause, rewind, anything, if I go a little bit quick, feel free to pause and rewind or do what you need to do to be successful going through this. So a quadratic equation contains a second degree variable in it. And we always want to make sure our quadratic equations are set equal to 0. One thing to make sure that you understand is when you are solving a quadratic equation, you are finding these zeros. A quadratic equation can be factored. In that case, it's written as a product of linear terms. And because of our zero property, let me scoot down here just a little bit. But because of our zero property, if you multiply two numbers together and get 0, then either one of them must be 0. Therefore, if you can factor your quadratic into two linear terms, then it must be true that if you set either one of those equal to 0, that you can then find the zeros of your quadratic function. Again, this is going to be our standard form that we write our quadratic equations in. I obviously skipped a lot of the text explanation here, so if you would like to pause and read through this and take notes yourself, you are more than welcome to do so. All right, let's get into some practice here. I want to factor and solve the quadratic equation x squared plus x minus 6. The way in which we are going to do that is we need to make sure that we find a number or a pair of numbers that multiply to -6, multiply to our C value, and add to our B value. Now, this is only the case when A is equal to 1. Notice A here is 1. We'll look at some more advanced ones here in just a little bit. But in the case where A is 1, you want to find two numbers that multiply to C and add to B. If you go through all of the possible factors of -6, and then try to add them, you would see that -2 plus 3 gets you -1. I'm then going to show you two ways in which you can do this next step. So I'm going to change my middle term into adding a -2x and adding a positive 3x. Notice if you were to combine these two pieces, you would get back to our original. Then we're going to do what's called factor by grouping. And just find the common factors of those two terms. For example, the greatest common factor of x squared and -2x is x. I'm left with x minus 2. The greatest common factor here is 3, and I'm left with x minus 2. I then see that my common factor between those two terms is x minus 2. And if I factor that out, I'm left with x plus 3. Notice, and this is only the case when a is equal to 1, that I could have just shortcutted and said, then therefore my quadratic must factor into x minus 2 times x plus 3. But I wanted to show you why that's the case. Then using the zero product property, I know that means x minus 2 needs to be equal to 0 or could be equal to 0. And so when x equals 2, this quadratic would have a solution or a 0. And x plus 3 equals 0 means when x is negative 3, I would also have a 0. So this is the first way that I want to make sure that I show you how to solve this equation. Let me show you another way. This next method is the same as factor by grouping. However, it allows us to use the box in order to organize our thoughts. What I mean by that is I'm going to write my quadratic on the inside of my box, and then I'm going to split my positive x into a negative 2x and a plus 3x. I then apply the exact same method of factoring out the greatest common factor of each one of the pieces on the rows. And then the same thing here, x, and then whenever I have a negative touching, it gives me negative 2. Notice that gives me the exact same terms that we did before, and you get the same answer, but it allows you to have a more organized method, which is really going to help when we get to something like example 2. In the case where a is not equal to 1, I need to find two numbers that multiply to a times c, in this case multiply to 36, and then still add to b. If I take all the multiples of 36, I know that I either have to have both positive or both negative if I'm going to be multiplying to a positive. Since I'm adding to a positive, I'm going to choose that they are both positive. I need them to add to 15, and so here's my pair right here. Now I need to make two linear terms, but it gets really tricky because if I were to do maybe like a guess and check method, this could be 1x and 4x, and then they might have to guess and check, or this might be 2x and 2x, and so that takes a lot of time to do. So instead, I would employ a factor by grouping method, and I choose to organize my factor by grouping in this box. So I write my 4x squared and my 9, and then I rewrite my 15x on my diagonal pieces here. I then factor out the greatest common factor, in that case x, in this case 3, 4x, and 3. And so I get x plus 3 times 4x plus 3 are my two linear terms. And you can always refoil and make sure that you get back to your original answer. By zero product property, I set both of these terms equal to 0, and then solve to find my two solutions. All right, let's do one more example. And unfortunately, my goal to get this in 15 minutes for the whole shebang, I don't think it's going to work. But let's at least get through example 3 and 4, and then there will have to be a part 2. All right, when I look at example 3, I don't have a quadratic. I have that my biggest factor here is actually, or my biggest degree, I should say, is actually 3. But I notice each and every one of my terms has an x, and they are all negative. So I'm going to choose to factor out a greatest common factor of my 3 terms, this trinomial, as negative x. I am then left with 3x squared minus 5x, plus 5x plus 2. All right, I now need to find 2 numbers that multiply to 6 and add to 5. Hopefully you can see that that's going to be the numbers 2 and 3. I keep my negative x out here, but I do need to find the 2 linear pieces of the quadratic. I'm going to write 2x and 3x on my diagonal. I factor out an x. Only common factor between 3 and 2 is 1. Here I have a 3x plus 2. And so those are my 2 factors of the quadratic piece, but I need to make sure I don't forget the negative x in the front. I now have 3 different pieces for possible zeros. So x could be 0, x could be negative 1, or x could be negative 2/3. Let's look at this last example. Notice I don't have a bx term. Also, a equals 1, so that's nice. I need 2 numbers that multiply to negative 9 and add to 0. That's going to be 3 and negative 3. Since a is 1, those are my 2 factors. And so I get that x could be 3 or x could be negative 3. In this case, where my bx term is 0, I call that a difference of squares. And it will always be the case that the 2 linear terms are x plus and minus the square root of your c term.